Hello, lovely people. How are you doing? Here is another video where we are going to be looking at the trigonometric identities involving sec, cosec, cot, and all that good stuff. And here we're going to start with a problem where we've got to prove the following identities. We need to prove that sec to the power of 4 theta minus tan to the power of 4 theta is identical to sec squared theta plus tan squared theta. Well, let's write down the identities that we need. So the main identities that we've got are, of course, the sine squared theta plus cos squared theta is 1, sine theta over cos theta equals tan theta, and we have the 1 plus tan squared theta is identical to sec squared theta. And we've also got the 1 plus cot squared theta is identical to cosec squared theta. Okay, lovely stuff. Now, let's get ahead of the question. So we know that sec to the 4 theta minus tan to the 4 theta is identical to sec squared theta plus tan squared theta. Or do we? We have to prove it. This left-hand side, we've got something to the power of 4, or an even number, take away something to the power of another even number. This is actually the difference of two squares. And this would factorize to sec squared theta plus tan squared theta multiplied by sec squared theta minus tan squared theta. Now, given using this identity down here, we know that if we rearrange it, sec squared theta minus tan squared theta is actually going to be 1. So this is equal to, this is equal to sec squared theta plus tan squared theta multiplied by 1. And that's just equal to sec squared theta plus tan squared theta. Look at that. That is what we were asked to show. So we've gone from the left-hand side to the right-hand side. So we are all good. Right. Next, we have cosec squared x minus sine squared x is identical to cot squared x plus cos squared x. Okay. Well. What can we do here? So cosec squared x, are there any things that we can say? Okay, well, we know that cosec squared x, I'm now looking at what's on this side here. So I can see a cot squared x in the thing that we're trying to get to. So how can we make a cot squared x out of what we have on the left-hand side? Well, we've got this identity 1 plus cot squared x is identical to cosec squared x. So I can replace cosec squared x with 1 plus cot squared x. And that's minus sine squared x. Okay, so I've done one thing. So I've got a cot squared x, but now my thing also has a cos squared x, but I don't have that in my thing. But I do have sine squared x. So I can replace the sine squared x. So 1 plus cot squared x can be replaced with minus 1 minus cos squared x, because this brings in the cos squared x that we need. And that's just using the identity that sine squared x plus cos squared x is 1, rearranged, of course. So then this simplifies to 1 plus cot squared x minus 1 minus cos squared x, which is the same thing as plus cos squared x. And this simplifies to the trusted cot squared x plus cos squared x. So you'll notice that when I do these questions, I'll be constantly evaluating, okay, I'm on the left-hand side, I'm trying to get to the right-hand side. What's on the right-hand side that I don't have on the left-hand side? How can I involve that? How can I get that incorporated? These are the questions I'm always asking myself. Let's look at another example. So I've got sec squared a multiplied by brackets cot squared a minus cos squared a. And I want to show that that is all equal to cot squared a. Right, so what could I do here? Well, okay. Well, I could do this. So if I expand this bracket, and the reason I'm expanding this bracket is because I still have my cot squared a involved, and that means the rest of it has to go in some way, shape, or form. So if I multiply out this bracket, I get sec squared a times cot squared a minus sec squared a times cos squared a. Right, sec squared a times cot squared a. Well, first of all, sec squared is 1 over cos squared a. And then cot squared is, well, I could, no, yeah, I'm going to write it as cos squared a over sine squared a. Okay, minus, and then here I've got sec squared times cos squared. Well, sec squared is 1 over cos squared. Therefore, sec squared a times cos squared a is just going to be 1. Now, on this side, I've got cos squared and cos squared, which cancel. So I'm left with 1 over sine squared a minus 1. Well, 1 over sine squared a is cosec squared a, and I subtract 1. I have the identity, the 1 plus cot squared a is identical to cosec squared a. And if I subtract 1 from both sides, I'm now left with cosec squared a minus 1 is going to be the same thing as cot squared a. So there we go. That's that one done. Okay, next one I have, let's write in green. I want to prove that 1 minus cos squared alpha theta is identical to sec squared theta minus 1 times 1 minus sine squared theta. Okay, this is interesting. I'm going to start with the right-hand side, and I'm going to try to get to the left-hand side. I'm doing this because the right-hand side looks like there's more to work with, so I'm going to do that. Okay, so if I start with this side, well, I also know that 1 plus tan squared theta is identical to sec squared theta. Therefore, sec squared theta minus 1 is the same thing as tan squared theta. So I can replace the sec squared theta minus 1 with tan squared theta. And that's multiplied by 1 minus sine squared theta. So, yeah, I'm going to do that. So multiply that by 1 minus sine squared theta. Okay, what can I do here? Well, I can change 1 minus sine squared theta for cos squared theta. So this becomes tan squared theta times cos squared theta. And tan squared theta is sine squared theta over cos squared theta. And then that's being multiplied by cos squared theta. This simplifies to sine squared theta, but sine squared theta is the same thing as 1 minus cos squared theta, using the identity sine squared theta plus cos squared theta is 1. And I've gotten myself over here to the left-hand side. So the more of these you do, the more you start to notice various things. Right, let's go to 2 more examples before we finish up. So on this one, I've got 1 minus tan squared a and 1 plus tan squared a, and we want to show that is equal to 1 minus 2 sine squared a. Okay, so looks like I'm going to be using the 1 plus tan squared a for sure is identical to sec squared a. So here I am going to, what am I going to do? Right, I'm gonna, okay. What I'm gonna do is say that this is 1 minus tan squared a over, well, 1 plus tan squared a is sec squared a, so I'm gonna put over sec squared a. And then that is gonna be the same thing as Well, dividing by sec squared is the same thing as multiplying by cos squared because it's the reciprocal. So I have cos squared A multiplied by 1 minus tan squared A. And then multiplying this out, I get cos squared A minus, well, if tan squared A is sine squared over cos squared, and that's being multiplied by cos squared, then that's the same thing as minus sine squared A. So again, just taking the time to think about that. Tan squared is sine squared over cos squared. So that becomes, just to write a little note, cos squared A multiplied by sine squared A over cos squared A. And then that simplifies to sine squared A. Just to make that clear. Cool, okay. And then, well, our answer only has sine squared A's and we've got a cos squared A. So let's change that also to a 1 minus sine squared A, using the sine squared plus cos squared is 1. So 1 minus sine squared A is that, minus another sine squared A gives us 1 minus 2 sine squared A. And that's it. We've proved it. We've proved that the left-hand side is equal to the right-hand side. Okay. Next, we've got sec squared theta plus cosec squared. Theta is the same thing as sec squared times cosec squared. Okay, what's going on here? Wow, the sum and the products are the same as each other. Let's also write the other identity then. We've got 1 plus cot squared theta is identical to cosec squared theta. What's something that I could do here? I think what I could do is probably just treat these as fractions and then add them. So when I say treat them, I can write them as what they are. So this is 1 over cos squared theta plus 1 over sine squared theta, because that's what those things are. Adding the fractions together, I end up with, so making the common denominators, just adding the algebraic fractions, I get sine squared theta times 1 plus cos squared theta times 1, all divided by cos squared theta sine squared theta, because the denominators get multiplied by each other. And then I've got sine squared theta plus cos squared theta, well, that's just equal to 1. So that's 1 over cos squared theta sine squared theta. Happy times. Oh, look at that. So I've got 1 over cos squared theta and I've got 1 over sine squared theta, just to write it out as products. That's 1 over cos squared theta multiplied by 1 over sine squared theta. Lo and behold, 1 over cos squared theta is sec squared theta, and 1 over sine squared theta is cosec squared theta. Now, these ideas, they seem a bit alien, they seem a bit wild. You might think, how, why, what's he done? Why has he decided to do these things? Honestly, it comes to trying different things, and it's okay to get stuck with this topic, but it comes to trying different things. And I think if you watch more and more of my videos, you'll see more ideas, and as you go and practice your examples, you'll be in an awesome position. So that's it for this video. I will see you in the next one. Take care for now.